Now you can also use models, as I said. And how would you do this with models? Well, what you want to do is assign the priorities. There's an H here. We draw this with numbers. 4 is going back. 1 is coming forward. 2 is in the plane to the left, and 3 is in the plane to the right. So what you can do is build a model, and we'll say 1 is red, 2 is blue, 3 is green, and 4 is white. So what would that look like if we built the model? Okay, so I drew on paper and took a picture the groups 1, 2, and 3, and I built a model, and you can see blue is 2. So this is 2 here, and green is 3. And you'll notice the way I'm holding this model in the picture, these two bonds are in the plane. I'm holding it carefully, putting the 2 and the 3, the blue and the green, in the plane. Now, group 1 is red. And notice that's coming out. That's coming out on a wedge. Group 4 is white, and that's going back. So what good does this do me, having this model built? So step 1 is to build it to match drawing. But then step 2 is to rotate it. So 4 is back. So you see, once the model's built according to the picture, then you can ignore the picture. The model's built, you can pick it up, throw it around, tumble it around. It's got its configuration. So now you just hold it, put 4 back. So in this picture, I'm holding the low priority group 4 behind the chiral center, and red is 1, 2 is blue, and 3 is green. So you know, if you do it like this, you can pick any color to be 1, 2, 3, and 4, and if you always do it the same way, you'll start to memorize your own pattern. So this is S. So a quick question is, are 2-butanol dextrorotatory or levorotatory? And if you ask me that, my answer will be, I don't know, because there is no defined correlation between absolute configuration, which is assigned R or S, and direction of optical rotation, which is plus or minus. How could you determine if this is dextrorotatory or levorotatory? Well, get a polarimeter out, make a solution, and measure the angle of optical rotation. Is it counterclockwise or clockwise? Or look it up. A lot of these have been deduced, and they're known. They've been measured, I should say. They're known. And so this is from Sigma Aldrich, where you can order chemicals, and we see, I looked up R2-butanol, and they provide both designations in here. In this case, R, absolute configuration, is levorotatory. It rotates plane polarized light in the counterclockwise direction. The thing to remember is that there is no correlation between these designations. So for 2-butanol, the R enantiomer happens to be levorotatory and the S is dextrorotatory. But for another compound, it may be the opposite. Maybe R is dextrorotatory. So there is no direct correlation that you can memorize between these two designations. Now, drawing enantiomers, what if you have one enantiomer and you need to draw the other? There are multiple ways you could do this. You could do a mirror image. And you could do mirror images multiple ways. You could reflect it this way. Okay, I could reflect it over here as well. So if you draw the reflection of an enantiomer, you'll get the other enantiomer. You can also switch two groups. So I left the methyl and the hydrogen alone, but I switched the OH and the ethyl groups. Now this one is R, and this is nice because 4 is going back. We have 1, 2, 3. So that's R. Now 4 is still going back. 1, 2, 3. And so this is S. So if you switch two groups, you get the enantiomer. What if after switching two groups, I switch another two groups? Well, each time you switch two groups, you change enantiomers. So I just switched two groups and I changed it from R to S configuration. If I pick any two groups and switch them again, I will go back to R. This is another interesting way that you can determine R or S. What is the most important thing that you need to do to determine R or S? After you get the priorities, you need to get 4, which is H clearly in this case. Where does it have to go? Back. So we want to put it where the chlorine is. And let's say you don't like rotating or visualizing and you don't have your models. What's an easy way to do this? Well, this is group 1. I'm sorry, 4. This is group 1. Chlorine is the highest atomic number. The propyl group will beat the methyl group. And those are the priorities, 1, 2, 3, and 4. But we want 4 to be back. So remember, this is the original. I want to switch 4 and what? What should I switch 4 with in this case? Switch it with 1. Because in the original, 1 is back. So I have 2 and 3. And I want to put the hydrogen here. That's 4. And the chlorine here, that's 1. Now, what is it I have here? Not the original, but I have the enantiomer of original, the mirror image. So that's important to keep in mind. Now in this structure here, 4 is back, so I can easily determine this is S. But that's not the original structure. That is the mirror image of the original. I've switched 2 of the 4 groups. So if I switch them back, that means the original was R. So that's another trick that you can do to assign R and S easily. What if you're asked to draw one enantiomer and that's all you're told is to draw it? You have no mirror image to look at to change to get the other one. You're just told, for example, to draw S 2-bromo-butane. Well, the first thing is to make sure you know what you're working with. It's butane with a bromine on carbon 2. And now you want to add wedges and dashes to make this 3-dimensional. Here's our chiral center. Don't forget there's a hydrogen here. So you want to draw this 3-dimensionally. So we take our butane. There's going to be a wedge and a dash. Dash is going back, wedge is coming forward. Well, where should I put the bromine and the hydrogen relative to one another? Which should be on the wedge and which should be on the dash? If you try to figure that out before you draw it, you will waste a lot of time. Take a guess. What are your odds of getting this right? You have a 50% chance of getting it right. There's only 2 enantiomers, R and S. So you know what you do? Just pick one. So this is my guess. And why did I pick this one? Because 4 is back. I made my life easy. So this is 1, this is 2, and this is 3. And what did I just draw? 1, 2, 3. That is R. So I got it wrong. I wanted S 2-bromobutane and I just drew R. So how do I draw S then? Well, I had a 50-50 shot. I got it wrong. So just draw it the other way. I'll just switch the H and the Br. I could have left the H and the Br alone and moved the methyl and ethyl to either side, switch those two. You switch 2 groups, you get the other one.